Welcome to GL Communications presentation on complete LTE simulation in lab. I will be walking you through the diagrams of LTE network, the lab setup, and all the components within it required to simulate this network. This is a general network diagram depicting the nodes and interfaces in a LTE network. All the interfaces and nodes can be simulated using maps, and the signaling between the nodes can be captured easily with our All-IP Protocol Analyzer. Packet Scan. This is our typical Lte Lab setup. You can see that the entire EPC, the evolved packet core, is simulated using maps. The EPC is working with a real eNode B connected to LTE-enabled mobile phones. The data request traverses from the eNode B to MME, then to HSS, signaling gateway, then PDN gateway, and to the data servers. All these are connected to each other using a switch. One of the ports in the switch is configured to capture and mirror the packets over all these interfaces. So, with a single packet scan, one can monitor all the interfaces such as S1, S6A, S5, and more over the LTE network. Here is the interface of our maps with all the nodes. As you can see, all the nodes within an LTE network can be simulated using a simple remote interface. I have configured the MME server, HSS server, signaling gateway, and PDN gateway servers with the respective system IP address and port numbers. I will save this configuration as a file so that it can be easily loaded later. Now I am going to start the server on all nodes. You can see that the color changes, indicating that the nodes are started. Let me go and start our eNode B. I am starting the eNode B with a set of predefined configurations saved as a file on a Linux system. This contains the IP address of MME, authentication algorithm information, the frequency band, power level, and so on. For eNode B to communicate with the entire simulated EPC, we need to start the test bed setup for each node. As you can observe, I am loading the test bed setups for each node and verifying the parameters. This is an HSS node test bed setup. You can verify all the parameters and save the configurations if necessary. Once the test bed setup are started, the SCTP link status must be up. You can verify this using the link status window. Verify the SCTP link status between the MME and HSS. Similarly, at the MME side, we may have multiple SCTP link status, indicating its connection with eNode B and HSS. You can verify the source and destination IP addresses here. Note that within a single window, you can access link status of all the nodes. This is the call receiving window at the MME side. Note the management procedures are successfully executed. These procedures executed when the link between the MME and the eNode B is successfully established. We can now proceed to send and receive data. Now I am switching on the LTE mobile phone. Mobile device contains a SIM compatible with eNode B used in this setup. Once the device searches for the available LTE networks, it automatically connects to the eNode B. You can observe a new entry in the call reception and initiation of the attach procedures by eNode B. Also note the authentication, security, and create session procedures in the call flow. Once we get a response for create session procedure, the attach procedure is completed. When the attach procedure is completed, the SGW and eNode B exchange their respective tunnel endpoint identifier for the uplink and downlink information. The decoded information of each and every message can be verified here. Now the complete data session is established. We can check data connectivity on the mobile device by browsing any website. I will now open our packet scan monitoring application to verify the captured packets and decoded signaling information. For each selected packet, I can see the detailed decoded view. This completes the LTE network simulation using maps.